Hello everyone. In this video, we are going to do the sorting operation in an array in ascending order using 8086 lab kit. So in previous video, we have understood how to do the programming in terms of your EMU8086 because those things are going to be very easy in terms of simulation. Here, a small issue is there. We can able to discuss those issues and we can able to see how we can able to program it in terms of your lab kit for ascending order programming. So we can just refresh what are the things we have seen. So we have taken an array, we have declared an inner loop and outer loop. After that, we have to declare the starting address of the elements in memory. And after that, we have to swap those elements and we have to compare those elements. If comparison needs swapping, we have to swap it, else do nothing. So we have to declare an inner loop and we have to declare an outer loop. And after that, we have to check for every condition and we have to do the operations for ascending order. So the description, I will give the videos of previous videos so that we can able to check before getting into lab kit. So here in terms of programming, so here we have used loop 1 and loop 2 and miss. So while you are seeing in terms of your lab kit programming, so we can't able to have these commands as like loop 1, loop 2 and miss. Instead, we have to declare the memory location exactly where the instruction is located. So in previous experiments also we have done the same. Here in this we are having a small issue, which means here we can able to, if you want to move it in terms of memory elements. So here after completing this jump no zero, I have to specify the memory location where exactly this instruction is getting located. So assume that it is going to it can be around 2006. So this 2006 location has to be specified here instead of this loop jump no zero 2006, and assume that this is going to be at 2002. So loop 2 has to be replaced with 2002. So this is fine. While you are typing your program, we know that when this instruction is going to be coming, right? So I can able to directly note down those memory locations in a notebook, and after that I can able to directly enter there. But see here, for this condition, till now I don't know where exactly I have to jump, because while typing this program I don't know where this memory location is getting being will be there. So for that, what I can able to do for an easy analysis, jump to an dummy location. Just give some dummy values, and after typing that program, you can able to understand after typing your program in your 8086 lab kit. So you will be using assembler A for typing your program, and after typing your program, so this memory location we can able to identify it by entering the dummy variable. You can able to start typing your program. So it can be of any values 2050. I'm assuming that this is the dummy value. So after typing this program, so when I am reaching this instruction, I know where exactly it is going to be placed. Assume that it is at 2020. I'm making a wild guess. So this location is 2020. After completing typing this program, so I know this location. So if I have missed this location, I can able to type the command U, and after that I can able to check for all the instructions. And while checking the instructions, I can able to check with the memory locations also. So I can able to take with the memory location. So after completing this program, typing this program, I have to remove this dummy variable and I have to put this 2020 inside this dummy place. So for that, assume that this is being located at 2010. So at this location of 2010, so I have to move there. If I have to move, I have to press A. While you are using this program, I will be giving 1000, right? This is the starting address of this program. If I want to move to 2010, so I have to press A, and after that I have to press 2010, so that I can able to move to this specific memory location, and I can able to change the things which I have already given. So that thing can be done. So like this, I have to type the program and I have to put it inside my uh, program memory. So previously I have to put a dummy variable, since because I don't know that where exactly this increment Si will be there. But here I know because I have typed it already and I have to put it here. So while typing this instruction itself, I can able to note it down. It is going to be located at 2000 and 2006, and I can able to put those values here. But while typing that in terms of your lab kit, it's not possible for taking this value, so that I will be putting a dummy variable and I can able to make use of it for programming. So this is how I am trying to do this program. So this is we can able to have this incrementation, which means like I have to declare my inner loop. So this is my outer loop, this is my inner loop. All those things are perfectly done. So after that I have to move Si, and after that move al comma si. All those things I can able to do that. So see here, while you are typing this program, so the inner loop has to move here, right? So the inner loop has to move here. I know the memory location. While typing this, I know the memory location. I can able to press enter and I can able to know this location. So after that one, I can able to in outer loop, I have to declare 1003. This is your outer loop. It will be putting in terms of 1003. The main thing which you have to be very careful while you are entering this value is this set of instruction. While you are typing this command, I don't know where it is being located. So you just put with some dummy variable 2050 or something, anything, any dummy variable. Don't execute that program. Before executing that program, after completing the typing this set of instructions, you just move to that specific location by pressing an assembler A, and after that reaching that specific memory location 1011, and I can able to give the command jc1011b. So this is how I can able to take this and I can able to put this inside my program. So in terms of input, I can able to give input in terms like in the memory location of 04, 05, 02, 03, 01. And after completing the program, it should be in this fashion 01, 02, 03, 04, and 05 in the specific memory location. I have to make it in that fashion. So after completing this one, I can able to get into real-time kit. So next slide, we will just move it into real-time kit. Yeah, this is your real-time kit, and this is your reset button, and this is your interrupt button. So while you are starting your program, you can able to have this kinds of words which is already been displayed. So while you are playing this one, you can able to press first we have to initiate it, and after that you have to do it, right? So first we have to type assembler A and you have to type your program, but I have already typed the program, so I will type U and I will press the starting address since already I have typed the program. I will move to that specific memory location. Yeah, I will get the instructions one by one done. So ch comma 05, it is the count in terms of your outer loop. This CL is going to be your inner loop. So SI is going to be focusing on the memory location where my data is getting saved. It is getting as a location of 1006, and after that 100A, which is going to be swapping those elements, and after that BL comma SI plus 1, I'm moving the next element to that one. So I am doing the compare operation here, AL comma BL. So while you are doing this compare operation, this will be compared and your carry flag will be set. So here we will be seeing JB, which is going to be jump borrow. Jump carry and jump borrow is same for your microprocessor. So it can be jump carry or jump borrow. You can able to declare anything. And after that, the next instruction move DL comma SI plus 1. And after typing it, I'm going exchange SI comma DL. All those things we have already seen in terms of programming. The same thing I have typed here. And I'm making use of this for my understanding. So after typing my exchange command, I have to swap those values. After swapping those values, I have to increment my SI so that it will move to in inner loop. It will move to the next two elements. And after incrementing this SI, so this 101B, so it has to be given there, right? So after that, jump decrement CH, this for your outer loop, and checking condition for your outer loop. After that, I am pressing halt. So this is the garbage value. After that, I have to press reset. After pressing reset, so I have to give SB substitute byte. I have to give the memory location 2000. So in that, I am trying to enter the values one by one. So first I have started giving the enter values as like the same 0, 4, and after that I am giving 0, 5, and after that I have to give the next element which is going to be 0, 2, and after that I have to give the next element 0, 3, and after that I have to give the next element 0, 1. So it is getting completed. I can able to reset it. After pressing reset, I have to execute my command so that it is going to be executed with go 1000 starting address of my program. It's getting executed. After that I can able to press reset, and I can able to check in substitute byte to that memory location of 2000. If I am going there, we can able to see the values in the ascending order fashion: 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So this is how we have to do our programming in terms of your lab kit. So while coming to lab, you can able to try this program, and you can able to get it verified with your ascending order. You just try it for 16-bit also. This is for 8-bit. You can able to try it for 16-bit also. Thank you for your patience listening.